Hello guys, how are you all? I hope you all are doing fine. Welcome back to vishnusmartinfo channel. This is your track to physics mentor, this side charusharma, and I hope you have seen the latest video of mechanical properties of solids, which was on thermal stress. The video was named as Mechanical Properties of Solids Part 3, and if you haven't, please go and watch it, and also put the thumbs up, like it, do comment. And I'm always requesting you all, the only method we have to interact, like if I am your educator over here, your mentor over here, and you people are here, we all have an interface between us, that is the social network and this YouTube channel. This is our YouTube channel. The only way we can communicate, we can talk to each other is by through comments. And if you are not commenting, how would I be able to know that are you liking the video or not? And if you are liking it, then why is it no support? Why there are so less likes? Because views are going high, but the likes are less. What should I understand from it? So, like, how you want the things, because everyone is teaching on YouTube platform, everyone is trying to help every student, and everyone is trying to make the education affordable and mostly free for everyone. But still, the only method you can support us is through likes and comments, but you all are not doing that. Please let me know at least why are you lazy to comment. Okay, at least spend your 1 second for commenting below down, please yaar, so that we can interact and we can come to know where what you want. Like, suppose you are finding something difficult, you can ask, no, that please try to bring something like this on your channel so that it helps us, like test series you want, or you want conceptual understanding videos, or you want like theory videos, or you want problem solving videos. Which type of content do you want? And whatever the content we are putting in this Astitva series, are you liking it or not? Like all the subjects content they are putting on the channel, so please let us know. Okay, I'm just a big request from you all. Fine, so let's start with today video, Mechanical Properties of Solids Part 4. So in the last class we discussed about thermal stress, and I put you one question also. What was the question? I repeat the question, and you can let me know the answers of that question in the comment box of this video also. And whoever will comment the first answer and the right answer, I will take that person name in the upcoming videos. So what was the question about thermal stress? Already the concept was taught in part 3 video. Now I am putting a question. This same question is there also. You can comment on that channel, on that video also. So what was the question is, this is a horizontal surface. On this horizontal surface I am putting a rod of any material, assume, and I am supplying heat to it. I am asking the question, what is the thermal stress on the rod? Thermal stress. What is its thermal stress? How do you denote thermal stress in this case? Okay, this is the question. What I am doing, I am supplying heat to it. This is a rod. This is a rod. This is a rod, and it is placed on a smooth horizontal surface. There are no fixed supports, and I am supplying thermal heat. So what is the amount of thermal stress in this rod? You should let me know in the comment box below. Okay, now everyone will think the video starting is only with a question, means we will not understand anything. No, I have already explained this thermal stress concept in the part 3 video of Mechanical Properties of Solids, so you can go there and check it out. And also from this video, you will have the link of my first chapter which I taught on the channel was gravitation. That playlist link also you can find in the description box below. Okay, so let's move ahead with today's class. That is the first concept, wires in series combination. Wires in series combination. In series combination. So what do you mean by series? just means like things are attached together in series like this, right? Together things are attached in a series are known as things attached in a line together. That is, we can call it a series combination. So a simple case I will take. This is a support to which I have hang one wire and another wire is in series with it. So there are two wires, A and B. Wire A and or let me name it as 1 and 2. So wire 1 and wire 2. Two wires I have in series combination. Now this wire 1 is having its young modulus as y1 and this wire 2 has having its young modulus as y2. The cross section of this wire is a1. The cross section of this wire is a2. The length of this wire is L1 and the length of this wire is L2. Now what I am doing, I am pulling the wire or stretching the wire, means applying force, a pull force here, F. So what you can observe, the first observation here is different values of the wire is given, but the force for both the wires is same, F, because I can't apply different F over here because here they are joined. So and here too it is support. So only place where I can apply force was this place, and in this place I applied a same force F. I can't apply two different forces for two different wires. So there is a similar same force on both. Okay. Now if I ask you the elongation, what is the net elongation? So what you will say, net elongation will be elongation of the first wire and plus second elongation of the second wire. What is meant by elongation is nothing but change in length. Like what will happen if this is your rod and if I pull it like this with F force, what will happen? The length, if suppose initial length was L, if you pull it, what will happen? The length will increase a little bit. That increased length, if I calculate, it will be L dash. So what will be the elongation? New length minus initial length. What was the new length minus initial length? You will get the amount of elongation. So that's what I am doing here also. So for net elongation, you need to take elongation of the first wire plus elongation of the second wire. Okay, elongation of the first wire plus elongation of the second wire. Now you know the simple formula that Young's modulus is equals to stress upon strain. And what is stress? Force upon area. And what is strain? Elongation upon original length. Okay. So this was y. So instead of that, can I write E is equals to FL by AY? What did I do? I bring y here and send E over here. That's it I did. So I got the elongation in this terms, FL by AY. So can I write E net as, force was same but area, but in place of net elongation I will write force into length. What was length? Means effective length, L1 plus L2. So L effective by AY, no? So area also we should write area effective. The area of this one, area of this two, area effective, net area. And also y effective, Young's modulus effective. What is the effective? Young's modulus, because this is having different, this is having different. So net elongation ke form mein you have to write like this. For E1, how you should write means same force F, L1, A1, Y1. Similarly, for E2, how do you write? F, L2, A2, Y2. So F gets cancelled. Okay. Now, here I took A1 and A2 different. So sometimes you can solve it like this. But most of the cases in questions, what they will tell you, know, that A1 is equals to A2. Both the areas are equal. In most of the questions, they put the areas equal only. So once area become equal, so I, instead of A1, A2, can I write only A? Instead of A1, A2, can I write only A? Yes, because areas are same. So L effective upon area effective multiplied by Young's modulus effective is equals to L1 upon A into Y1 plus L2 upon A Y2. Yes, so if you solve this, can you see that? Okay, so now if you solve this, If you solve this, what you will get? That y effective is equals to L1 plus L2 divided by L1 y2 plus L2 y1 into y1 y2. This will be your answer. So you need to take LCM and solve. That's it. Okay, no big thing I did. Whatever the term I gave you, just take LCM and arrange a tree properly. You will get this formula. So for y is in series combination, what is your formula? Y effective is equals to L1 plus L2 multiplied by y1 y2 divided by L1 y2 plus L2 y1. Okay, L2 y1. So what is y? It's effective Young's modulus of this series combination. Now here I took the case of 2 y's. You can even take 3, 4, like whatever is given in the question. Then what is L1? L1 is the length of the first wire and L2 is the length of the second wire. What is y1? Young's modulus of the first wire, and y2 Young's modulus of the second wire. So like that you need to solve. So what was the concept in series combination? Two key concepts you should catch it out in series combination. What is? First of all, you need to go ahead with E net. Net elongation you find. Meeku net elongation etla find cheyalante E1 plus E2. Malli meeku telusu ఈ ఫార్ములా నుంచి రీషఫల్ చేసి ఎలాంగేషన్ని ఈ ఫార్ములా టర్మ్స్లో పెట్టి మీరు సాల్వ్ చేయాలి. సో ఫస్ట్ కాన్సెప్ట్ ఈ నెట్ తోటి పెట్టాలి. నెట్ ఎలాంగేషన్ ఫైండ్ చేయాలి సిరీస్ కాంబినేషన్లో. సెకండ్ కాన్సెప్ట్ ఏం పట్టుకోవాలంటే ఫోర్స్ సేమ్ ఉంటుంది. ఓకే, సో ఇన్ సిరీస్ కాంబినేషన్ ఫోర్స్ will be same and net elongation you should find. That two key concepts. So for everyone will think physics is very hard. Even I used to think first, like, because you should buttify so many formulas, you should remember so many things and all. But no, when I understood it properly, it is just simple concepts. If you know y is equals to stress upon strain, you can solve any sum from this basic in exam. Okay, like this mechanical properties of solids ka. But to derive that all in exam, probably it will take more than 1 minute, and in neet exam you are supposed to do 1 minute one sum maximum. So uske liye you cannot afford solving or deriving the formula by yourself in exam. So if once you know the basic concepts and once you are practicing and once you are learning the theory effectively and by yourself in your practice time, you are deriving the formula 2 to 3 times by yourself and then doing 10 to 20 numericals on the same formula, obviously this formula will fit into your mind. Okay, so there is nothing like buttifying. Okay, never buttify. Without now someone what he will do, he will open he or she the person will open the mechanical, suppose test is there for mechanical properties of solids, that person will open the book and he will say, tomorrow I'm having test, so I will learn the formulas. So randomly he will learn this formula. Y effective, whenever a question comes for y is in series combination, you should apply this formula. Now in exam there is no details about y1 and y2. So he is in a loss because he'll learn the formula of y1 and y2, but there is no detail only in the question. So what he will do? Either he will do the wrong sum or he will leave the sum. But instead of that, when he was doing practicing, or he was when he kept his practice time on the core concept, he should remember, or he should focusly listen that whatever the mentor or teacher, whoever was teaching him, that sir or ma'am told us that in series combination what are the two important things is net elongation and force should be same. So these two key concepts you remember, you can solve the sum automatically. You should not bother about the formula. Okay, and this formula, when you do a 2-3 sums on series combination after understanding the concept, this formula already fits in your minds. So whenever if y1 y2 also not be, given, a student who has studied the concept properly will not bother. he will find out some other way, because he know the concept that we should take E net elongation and we should consider force should be same. So like that you should improve your physics. It's not like a one day cake. Okay, you should work hard or not on it. Okay, fine. Now let's move on to the second concept or application, which is wires in parallel combination. Wires in, and one more thing, I came to a conclusion that people are not, when I was posting small duration videos now, I got more views. Means people are interested, or students are interested in the conceptual videos, but they need a smaller duration. If the video is stretching up to 44, 50, 60 minutes or more than 1 hour, then they students are not getting or not sitting, what I say, they are not watching the whole lesson. So if the same conceptual videos are explained in small parts, like just 14 to 15 minutes, you can easily cover it off whenever you are in a traveling mode, or just when you're finding some free time. Just 14 minutes you listen a video, you understand some concepts. So I am trying to do that only. So hardly 20 minutes like that videos I will take and I will post. Okay, so wires and parallel combination. Wires in parallel combination. So parallel means from smaller classes, or what I say, initial classes, or 6th, 7th, not 6th, 7th also, from 5th or 4th class also, you should know that what is meant by the word parallel. What is meant by the word parallel? The two lines which always are best friends, go together and never meet. Okay, so always go together and never meet is a condition of parallel. So here what is like this, you have two parallel wires. Okay, this is wire 1 and this is your wire 2. Wire 1, wire 2, and for example I'm there though I was applying some force. That force also you can consider some weight was applied, like mg you can consider. Sometimes they may give in that form also. Now what I'm doing, I'm instead of applying force, I'm considering that these two wires are attached to a same weight W. This weight log is having a weight W. Now the first wire ka Young modulus is y1, and area also you should consider here different only. And as they are in parallel, so I can't do parallel means this is not parallel, no, like this case you should not consider. This is a wrong, because here length is changing, L1 and L2, this is smaller and this is bigger. You should not consider this case in parallel. What is considered in parallel cases? Same length. So this is also L and this is also L, same length wires. Okay, the second wire Young modulus is y2 and area is a2. So this is the condition. So what are the two concepts over here again? In wires in parallel combination, firstly elongation is same. In that was force was same. Here elongation is same. Length you should take same. These two conditions are there. Means whatever, how this weight will pull na. So if this weight is pulling, by how much this wire will extend, by that much only that wire will extend. Because if they are unequally extending, this condition won't be in a parallel state. So to remain in a parallel state, the elongation should be the same. And to make the elongation same, initially we should take the length of the wires also same. That is L and L. Okay, so these two key concepts. Here force will be different. What will be different here? Force will be different. Force will be different. So in parallel combinations, elongation is same, L is same, but see this weight, it will apply some different force on this wire, some different force on this wire. Okay. So force, how do you write from this formula? Y is equals to F L upon A E. So from this force is equals to Y A E upon L. Is it? Did I do correctly? Yes. So now net force you should find. What is the net force? Net force is F1 plus F2. There we found net elongation. Here we are finding net force. So how do you write net force? Now only I told you. F is equals to, oh you can't see, here I write F is equals to A Y E upon L. I used to remember force is A by L. A by L. So A by E by L. A by L. So F net is equals to F1 plus F2. So for F net, you can write net effective Young's modulus into net area, that is A1 plus A2, into elongation, or I can say E, divided upon L, because length is same for both the condition, is equals to, in place of F1 you will write first area, first wire ka modulus, and elongation is same, so E only, divided upon L, plus second wire ka area, Young's modulus of second wire, and elongation is same, divided upon same length. So EL will get cancelled. So what you will get? Y effective is equals to A1 Y1 plus A2 Y2 divided upon A1 plus A2. This is the Y effective formula for parallel combination. So in exam it's very hard to remember na, like which is parallel combination ka formula and which is series. Instead of that, concepts you should remember. In series, what we should consider, force was same, elongation was different, and we should say net elongation is equals to E1 plus E2. And in that series combination also you should consider area to be same. Now coming to parallel combination, you should consider forces are different, so we should consider F net is equals to F1 plus F2, and here you should consider elongation to be same, length should be same. Just 3 concepts, 3 points series combination, 3 points parallel combination. No need of buttifying this formula or just understand the application, how you apply. So in parallel cases, again I am telling, force will be different, F1 plus F2, obviously na. See, this wire different material, this wire different material, and this weight is pulling like this, means whatever the force experienced by this wire obviously will not be experienced by this wire. Assume how, I have 2 fellows. Okay, I have 2 fellows, and like in gymnastics they are doing, and they have put their legs like this, and okay, so they are hanging down like this, assume. So 2 fellows I have. One fellow is very fat and he is hanging like this and catching the log like this. Now then other fellow is also there, but he is very lean one, very thin person. Okay, both fellows, this is fat one, this is thin one, but one common thing is that their length is same. Whatever the height of this fellow is, the same height this fellow has. So now this log, they are trying to hold this log. So if they are trying to hold this log, whatever the force this fellow is experiencing or this fellow is applying is obviously different from the fellow this is applying, because their area of cross section is different, their sizes are different, means this ka Young's modulus is different, this body ka Young's modulus is different. That's why we should consider that forces are different. So F net is equals to F1 plus F2, net force what you experience over here, and the length consider same, and elongation also same, because suppose this block, this whatever the log or block is there, it goes down by this much. By this much height it goes down. So this much elongation you can see, na? This much elongation. So this block was originally here, now it came here. So but the hands of this fellow also stretch that much, and similarly hands of this fellow also stretch that much. The stretching of the hand doesn't depend upon their area of cross section. Okay, because their initial height we took same. Okay, I hope you understood it very clearly. So what is the parallel combination ka final formula? Y effective is equals to A1 Y1 plus A2 Y2 divided by A1 plus A2. So that's it for today's in this video about wires in parallel combination and series combination. I explained very clearly. I hope you like it. Please do comment, yaar. Comment. I am requesting you a lot as a friend. Okay, because I am of your age only. I'm trying to do my best. So please do comment and let me know, are you liking the videos, are you liking the teaching strategy and all. Okay, thank you for watching the video. Have a good day. Bye bye, take care.